Welcome to a new lesson. From this section, we would look at the most important and core topic, MapReduce. Let us first start with looking at the terminologies that are used in MapReduce. First is the split. Split is nothing but the fixed chunk of data that would serve as the input to map tasks. Just want you to remember that blocks and splits are two different concepts. Keep in mind that blocks are HDFS concept and belong to the HDFS world, and splits belong to the MapReduce world. Blocks are the smallest size of the data stored in HDFS, and split is the data that is input to the map jobs. MapTask processes this split and produces an output. In the diagram, I have shown that the map output is smaller than the map input size. This is the general and a good case, but I do not want you to think so, that it is a restriction. It can be equal or even larger than the input size as well, but that case is not a good case. It would be advantageous if it is as small as possible. We'll see later why. So when you think of MapReduce, the problem is divided into two portions. First is the map part and the second part is the reduce. All map jobs run in parallel and produce output. All the results are stored and shuffled and merged together into a file which serves as the input to the reduce job. The reduce job takes this as input and produces the result. The whole job execution is controlled by two nodes, job tracker and the task tracker. You can draw a parallel between name node in HDFS and job tracker in MapReduce. Corresponding to data nodes, there would be task trackers in the MapReduce world. Like the data nodes used to store the data, task trackers run on each data node, facilitating running of map tasks and the reduce tasks. Job tracker's job is to manage scheduling tasks to be run on task trackers, and it is task tracker's duty to run map and reduce jobs and send progress to the job tracker. Again, I want you to imagine job tracker and task trackers as a Java jobs that are running on the machines, and they are not the hardware. One more parallel between HDFS and MapReduce world we can draw is that like the name node's failure is a more serious one in HDFS, likewise here in MapReduce world the job tracker's failure is the more serious one, as all the jobs in progress and task tracker status will be lost. That is why it is wiser to spend more on the hardware that runs job tracker. Now let us run through the simulation again and try to understand the phases in a little more depth. Developer has to break the problem into two portions. First is the map phase and second is the reduce phase. The map jobs would work on the data which is located on the node itself. This principle is known as data locality. It is important that map jobs get their input which are local. If they are not local, they would be needed to be fetched from the network, and so latency would be added in network I/O and the performance would degrade. Hence, optimal value of split size is equal to the block size, as one complete block would be present on one node. Thus, every map would have its split located on the storage itself, and so split would be equal to block. Then the map task would carry out its process and write the output on the local disk and not on HDFS with replications. It is to be noted that the map output is written on the local disk as it is an intermediate result and is of no importance after the final result has been calculated. Hence it is stored only till the time the reducer has picked up and processed it successfully. It may happen so that the reducer may fail, and in that case job tracker would reuse the map output. So job tracker cleans up maps output only after the successful completion of reduce job. It is to be noted that the maps output would be returned to HDFS only in the case when 0 reducers are specified. In that case, the maps output is the final result, and final result has to be stored on HDFS as it increases the resilience to loss because of hardware failure. Next phase is shuffle and sort. All the maps output is merged, sorted and partitioned. So there are three steps that have happened. First is the merge which is nothing but combining the output of all the map jobs. Second is sort, which is sorting the map output based on key. And third is partitioning, which means that the output is divided based on the key value. Then comes the reduce phase. As you can see that the reducer won't get the data locally. It would be fetched from the network. Second thing to be noted is that the number of reducers are not decided based on the input size, like in case of maps, which is dependent on input size and split size. The number of reducers are decided independently. Reducer's output is returned to HDFS with replication for reliability. After a long process, results cannot be afforded to be lost because of hardware failure. So they are stored on HDFS, which is more resilient to hardware failures. If it is getting a little too much, just relax. We would run our first MapReduce job and things would be a lot more clearer then.